Hi everyone, thanks for joining. My name is Schömbs and today we're going to talk about our paper on uncertainty visualizations and embodiment in robot-assisted decision-making. Enjoy. Robots can be deployed in various domains and environments, from industry to healthcare to environments that pose safety risks to humans, while collecting data to support human decision-making. However, data is subject to uncertainty, and thus robots have to act under several sources of uncertainty. The communication of such uncertainty holds the potential to enhance transparency, to reduce risk, to align trust, and to support assisted decision-making. And yet, conveying a robot's uncertainty in a robot-assisted decision-making task has rarely been addressed so far. We explore robot-assisted decision-making in a high-stakes scenario with a robot that either conveys its confidence through a graphical interface or a robot's behavior, in the following referred to as embodied uncertainty visualization. We further explore different levels of confidence conveyed by the robot. Overall, our work is guided by the following overarching research questions. How do different modalities of a robot's uncertainty visualization affect the user's decision-making in a high-stakes robot-assisted decision task? And second, how does a robot's visualized level of confidence affect the user's trust in a high-stakes context? We contextualized our study in a human-robot collaboration setting, which resembled a packing station in a factory that produces pills. In our study, participants were told that they would examine pills from a factory in which a mishap has happened, due to which some pills might be defective. To support their decision-making, a robot was implemented to assess the content of each pillbox and to visualize its confidence in sensing if the pillboxes were defective. In detail, we conducted a 3x2 mixed design lab study with 36 participants, with the type of uncertainty visualization as a between subjects factor and the level of confidence as a within subject factor, to make inferences about the user's perception of the magnitude of uncertainty that is visualized by the robot. In total, each level of confidence consisted of 10 pillboxes that needed to be tested and collaboratively packed. Based on our manipulation check and prior research in information visualization, we investigated a part-to-whole icon array as an established visualization technique for uncertainty. For the GUI condition, we mounted an iPhone onto the robot's end effector, which we then used as a GUI to convey the confidence. For the embodied visualization, we drew from previous research on hesitation gestures and nonverbal signals in HRI to guide our design. And we implemented two functions to convey the robot's confidence through hesitation. The first function described the waiting time, how long the robot's gripper basically hovered above the target pillbox. The second function describes the travel time, basically the time the robot needs after picking up the pillbox to approaching the target position. We were particularly interested in investigating how the type of uncertainty visualization and the degree of uncertainty affects the user's decision-making. We thus asked participants to decide whether the package is ready for shipment or needs additional testing. Besides their final decision, we were also interested if participants changed their mind during the decision-making process, and in the user's perception of the robot that conveys uncertainty. In specific, we assessed participants' trust after each conveyed level of confidence and trust-related subdimensions, in our case, perceived transparency and perceived performance of the robot. Let's have a look at our most important results. In line with our manipulation check, our main study shows that participants successfully distinguished between low, high, and 100% confidence, and thus perceived our manipulation as intended. Next, we calculated participants' decision accuracy to get insights on our first research question. Considering the context of the task, we defined a correct decision as the judgment to send the package off to shipment if the robot conveyed 100% confidence. Otherwise, additional testing would be needed. Notably, in the 100% confidence condition, 12 out of 18 participants in the embodied group correctly decided to send all 10 packages into the ready for shipment pile, contrary to only 7 out of 18 participants in the GUI group. We further conducted an analysis on how many packages participants decided to ship, depending on the actual probability. Our findings show that participants who experience the embodied visualization place significantly more packages to the ready for shipment pile compared to participants who experience the GUI. We additionally assessed if participants changed their mind during the decision-making process, and interestingly, in the 100% confidence condition, 6 out of 18 participants in the GUI condition changed their mind compared to 0 in the embodied condition. Participants' overall trust was descriptively high across conditions with no significant effects, and notably, we observed a significant effect of confidence level on perceived transparency. Participants in the high confidence condition perceived the robot as significantly more transparent compared to the low confidence condition. Besides quantitative data, we also collected and analyzed qualitative data using a thematic analysis. Our findings show that the majority of participants in the GUI condition applied a personal risk threshold to make a decision and indicated a very high risk awareness. Surprisingly, several participants in the GUI condition interpreted the 100% confidence condition as the robot being overconfident and too confident. This perception made participants feel uneasy and caused them to distrust the robot. Lastly, some participants in the GUI condition expressed concerns regarding a lack of information and the need for further explanation in order to believe the robot. Contrary, participants who experienced the embodied uncertainty visualization expressed a rather binary perception of the robot's confidence retrospectively, with the robot being either confident or not confident. Besides, few participants also indicated that they were willing to hand over the decision-making fully to the robot. Let's have a look at our most important implications. Based on our results, future applications have to carefully consider the type of visualization and the expected confidence range to best support human decision-making in robot-assisted decision tasks. In detail, our study shows that repetitively visualizing 100% confidence can be a double-edged sword. The GUI-induced skepticism of a robot conveying 100% confidence can be both a hindrance or an asset, depending on the application context and goal of the task. A robot using a GUI enables users to, for instance, assess a risk in detail, to define or to apply a risk threshold. However, this approach may also lead to incorrect decisions caused by overthinking, distrust, and changing mind, potentially also impacting decision speed. Based on our findings, we suggest that an embodied visualization could nevertheless be useful for low-stakes scenarios and the decisions that require an intuitive understanding of the situation. Lastly, we recommend that low confidence and thus high uncertainty displayed by a robot should be further explained and contextualized to support user understanding. Thank you for listening. You can find more details of our study and results in our paper.